This conference will now be recorded.
Hello, my name is DigiFoF, and today I have a great pleasure of introducing next webinar from the DigiFoF webinar series. Today again, our presenter will be from Continental, and Christian Mihucoiu will present us the topic AGV for modern logistics in industrial companies. Before I switch the screens to Christian, one slide with technical aspects. As in the previous cases, you should have your microphones muted. If you have any questions, please expand the GoToMeeting panel, and there you can enter your message in a chat. So put any questions in the chat window, and we'll be answering them at the very end of the session. And you can pick whether this will be sent to a given person or to all participants. So this is for technical aspects. Of course, as in previous cases, this session is recorded and it will be available on YouTube. And now, without further ado, I'll switch screens and send it to Christian, and Christian will take over and tell you more about usage of AGVs. So Christian, floor is yours.
Hello, everybody. I'm happy to be again to speak with you. And today I will present you some slides about AGV for modern logistics in industrial companies. So today we'll talk about two main chapters in this presentation. We'll talk about hardware, about AGVs, and then we'll talk about software side of this content. When we talk about hardware, we will see smart equipment, which is the definition, how we select an AGV, a detailed description of the AGV, and we will talk also about rack design and standard LE in terms of using the AGV in our plant. First, let's understand what is a smart equipment. We define the smart equipment as machines that are capable to adapt automatically and modify behavior to fit environment. Machines that sense things with technology sensors that provide data to analyze and to use for their activity, that are taking conclusions based on the rules, machines that are capable of learning and using experience to improve performance. Technologies that allow sensor databases and wireless connections to sense, to adapt, and to provide with the user within the environment are included in this category of smart equipment. So to put a smart equipment, to classify an equipment as a smart, this machine must be intelligent, must be interconnected and autonomously communicating with the rest of the value chain of value creation. Smart equipment can be best defined in terms of characteristics. So I identify 8 characteristics that can put an equipment into the category of smart. First of all, must be multi-production, then scalable, modularized, standardized, interconnected, intelligent, and green. Let's talk a little about each of these characteristics. When we say multi-production, here we talk about the ability to produce different products which run different process flows on the same production lines. It will make our equipment highly utilized and the shop floor space more efficiently used. Here, multi-production means that you put different product at the beginning of the line, and each of the product can jump one step or can bypass one step different from type to type. There are products that can jump the second or the first steps, and other products, other categories that goes to those steps and jump other steps of production. In this way, we have on the same line multiple products. one smart equipment must be also scalable. Because of the frequent reconfiguration, we need to have an easy modification in terms of size and production volume by ensuring simple hardware mechanism as well as scalable software. Scalability in the production area is the key requirement to optimize future investment. So scalability refers to the possibility that increase the capacity of the line, let's say with 50% by adding another equipment on the uh, bottleneck area, or if you need to reduce the size of the line, you just remove some equipments and you make the line smaller, and you put on that line lower volumes. So scalable in terms of volumes, it's a characteristic which is very important in our day-by-day environment, which is very volatile from day to day. When we talk about modularization, we need to assure easy disassembly and assembly by having predefined modules. Sometimes you need to build a line from equipments in few days. You just have the equipments there. You need to be able to put one close to the other, plug all of them, and to have the line started in terms of hours, if not days. Modularization, it's a very important characteristics related also with scalability of the line. Standardize means using a standard way of equipment and layout design for hardware, uh, same as using standardized software, programming, and communication protocols. It also include qualified manufacturing technology from standard supplier. Standardization, it's one key characteristic in order to have modularization and scalability. If you do not have standards for communication, for let's say software, all the line to communicate to the same uh, manufacturing execution system, MES, or to communicate with the same database or the same clouds, it's very difficult to build a line or to, let's say, to work on scalability or modularization. These elements on this page are very tight one after the other. So if the line is not standardized, it will be really difficult to have scalability, modularization. So multi-production will not be possible on these lines. Other characteristics which define a smart equipment is the level of automation. Not only the core processes, but also product handling between one process and the other, material replenishment, ordering of material for replenishment, evacuation of the finished products must be also done in an automated solution. Interconnected relate to equipment that is horizontally connected with other processes and machine, and vertically connected with upper level control system. When we talk interconnected, to give you an example from our plant, we have a production line that is able to send to the warehouse information that in less than 2 hours, one raw material will be finished, and then the system automatically send the raw material using AGVs to that line. So we have a very interconnected processes here in the plant. Intelligent means ability to collect data and analyze it for real-time monitoring. Future predictive maintenance and troubleshooting is possible here. We have lines that are able now to identify problems due to vibrations, due to worn out parts, and are able to send this information to the maintenance team in order to plan the maintenance activities on the right period of time in order to affect as less as possible the production. Last but not least, the modern line must to be green, must to have as much as possible the energy consumption optimized, to have a self-energy control in case of idling, and all the characteristics that allow the line to consume energy only when it's really necessary. Now let's enter in the details and talk about AGVs. We understand by AGV automated guided vehicles. Sometimes we find double AGV. First A in this case means autonomous automated guided vehicles. AGVs are an example of smart equipment, are generally used to carry heavy materials in factory buildings or warehouses. Can be used for taking over and handling over, defined reusable packaging, as well as automatic transport between defined pick-up and drop-off points. The system operates self-guided and recharges automatically when required by means of fixed position charging stations. AGVs can guide themselves using one or more of these many means of navigation. Uh, can be wired guiding or guide tape. There are also laser target navigation in operation, inertial navigation, vision guidance, and geo guidance. There are all these ways of guide. The AGV are defined based on the application, based on the environment where the AGV will run. Depending on their applications, we have several kinds of AGV. We have towing vehicles, also called tugger, which is the first type introduced, used as like a locomotive to pulling a multitude of trailer types and have capacity ranging from 1 ton to 75 tons. Usually the tugger are the devices that have on their tail several carriages and that follow very strict route based on wire or tape. It's still used on the industry today. AGVs, unit load vehicles, the system that we have in Conti Sibiu, it's equipped with decks which permit unit load and unload transportation and automatic load transfer. Decks can be lift or lower type, powered or non-powered rollers, chain or bell decks or custom decks with multiple compartments. So AGV, unit load vehicle, in this case, there is an AGV that on top of it have a system to take the charge, to load the charge, and then when he reached the destination to unload the charge. We use in ContiCBU the system with rollers, with powered roller. Also, we have pallet trucks designed to transport palletized loads to and from floor level, eliminate the need for fixed load stands. So the AGV pallet trucks, it's able to identify the pallet and to lift it and transport it in a different location. Also, some details about smart equipment. AGV fork truck can service loads both at floor level and on stands. In some cases, these vehicles can also stack loads in racks, can sometimes lift heavy loads to high distance or retrieve from high bay racking. AGV hybrid vehicles are adapted from a standard man abroad truck so that they can run fully automated or can be driven for a four truck driver. But in some cases, it's better to have separate application. If you have man drive or AGV, which is automatically, it's more difficult when you have both on the same machine. Light load AGVs, as we have in Conti Sibiu, are a vehicle with capabilities to transport, in our case, around 50 kilos, small dimension packages. Use it for this load is not so high, but distances are quite long. Sometimes several hundred meters from the loading point to the unloading point. When we talk about selection, which AGV is the best one for what we need, we must take into consideration several characteristics. First of all is the payload, is the quantity that can be transported by the AGV. In our case, we have an AGV model AD90, which can transport 90 kilograms. The problem is that half of this load, it is the superstructure, the system that automatically load and unload the box with raw materials. So in our case, the quantity that we can transport, it's around 45-50 kilos due to these superstructures. Then we need to have standard stock unit, which means we need a KLT, we need a standard box to be able to be transported by the AGV. Otherwise, it will be very difficult because the AGV don't have system to recognize dimension or types of boxes. So standard stock unit is very important when you define the AGV that you will need to you need it for transportation. So the AGV must be able to manipulate this standard stock unit. ESD, in our case, because we are a plant of our electronic components and electrostatic discharges are a very high risk of damaging the products with very dramatic consequences. Sometimes everything in the plant must be ESD proof. So in this case, the model, the AGV that we need must to be electrostatic discharge proof, safe. Otherwise, it's not possible to use it in our production environment. Let's talk a little about the component part of the AGV. First, the platform. LD platform is a general purpose mobile robot platform designed to work indoor and around people. It is self-guided and self-charging with an automated docking station. The system, this platform, LD platform, it's coming from the Omron company, and we use it in our plant as the best, for the moment, as the best approach, the best performance for our applications. The platform includes the navigation laser, include front bumper with flow front laser and two rear facing sonar. In all of them are built in this platform in order to make safe operating of the AGV. The platform core include integrated computer, running, advanced robotics automation management, which we'll see later, and the microcontroller firmware. It also runs an operating system. The core is housed inside the platform, as you can see in this case. So it's the AGV has his own brain that operates him, and this brain is connected with the other components of the system in order to be able to run. The AGV, it's operated, so use a system of two wheels with differential drive, with small wheels in front and back in order to can change easily the direction. Wheels are the platform midline, so the platform can turn in place. So you can see the AGV turning around on the same place on the shop floor. Control unit and communication unit are included into the AGV and are optimized for an easy control and cooperation between the AGV and the fleet system for the entire AGV system that we have in the plant. communication unit, we have enterprise manager is the software solution that helps to manage the fleet. Enterprise Manager appliance can communicate with the AGV fleet and perform a variety of fleet-oriented tasks. System consists of a mobile robot software suite running on each Enterprise Manager appliances. So there is a central software, we usually call it Fleet Manager, and applications module of this software you can find on each AGV, so to be easily to connect to the fleet and to perform the operations in an automatic way. Also, the AGV is with built-in with brakes and sensor, because the AGV usually or most of the time operates on areas where will meet pedestrians. So the safety of the AGV is very important, which it's a very important issue. So using brakes, using sensor, using lasers, the AGV is able to identify which are the obstacles, which are the pedestrians that he meet in order to avoid any collisions. Here we'll see the operator panel. I will give you a short description of main elements, which include a screen with details, stop button, on off, brake release button, and key switch, which you can lock in either position and remove the key. With this on this operator panel, you can see the task that the AGV is doing. You can release the brakes in case that the AGV is blocked. So you can manually push it until we reach standard position, and then you can reinsert it into the fleet. Let's talk a little about rack design and standard alley. It's a very important issue that during the operation, the AGV will meet on the road, on the route from pickup points to drop off, will meet a lot of obstacles. Sometimes the route it's let's say shared with the operators, with pedestrians, with other milk run, that operate on the same area. So in this case, we need to define some rules, which are the areas where the AGV need to take care. So we have defined that for this kind of AGV, LD90, that in case the AGV goes only in one direction on that alley, the standard wide must be 1,600 millimeters wide. In case that there are two ways AGV and also pedestrian walking on that area, the standard alley must be at least 2,200 millimeters wide. In case that the wide of alley is smaller, the AGV need to reduce the speed in order to avoid collision. But this speed reduction will increase the transport time and will reduce the efficiency of the transportation. So it's very important to put together all these restrictions, the space that is available, dimension of the alley, traffic that are going on the alley, together with the speed and the performance that you need for the AGV, and to define the best, the optimum solution in terms of safety, which is on the first place, and then in terms of performance. Based on this restriction, we have defined racks for loading and unloading, and we have, as you can see here, a system with two decks. One is for loading and the other is for unloading, but this system is not so efficient in terms of space, and also is not efficient in terms of time, because after the unloading, the AGV must to go out and come back on the let's say, loading empty KNT position. So system is not so efficient in terms of time and space needed, but the system, let's say the rack, the superstructure of the AGV, it's much more cheaper, and you need only one level, as you can see here. It's very easy to drop off on KLT and then to pick up the empty one on the same bed of rolls in this case. We have also a system with double decks. When you the AGV drop the full KLT and then unload the empty one, but in this case space is much more optimum utilized. The AGV don't need time to reposition, but the superstructure it's a little more expensive, and you need more sensors, more details on the superstructures, which make it a little more expensive and a little more heavy in this case. So you need to find which is the best optimum in depending on the environment, on the production environment. If you have enough space and you don't have a problem with capacity transportation, then it's better to use a platform with separate unload and load empty instead of using one solution with double deck. If your in production environment it's heavy loaded, you have high density of production machines or a lot of people working around, and your space there is not so let's say available for all these machines that you have there and all the appliances, then it's better to use double deck solution. We have also here some details about track design. As I said, the AGV must to maneuver, must to go from one deck, one position to the other. So the AGV must go outside of the yellow area in order to position to, after unloading, to position to load the empty one. And for the double deck situations, you can see the space is reduced by half in this case, but superstructure of the AGV, it's a little more complicated and a little more expensive. Also, we have some requirements related with the docking station in such a way that when the AGV is entering on the charging position, to avoid collision with his colleagues or with other elements in the area. This is about hardware part in a few slides. Let's talk about now about the software that is needed to run an AGV fleet. We have some elements. We have advanced robotic command language, which is the operating system for the cobots. Then we have fleet management, is the application that take care about all the robots, knows in every moment where is it each of them, allocate task. Then we have traffic management application, charge management module, fleet docking, and manage motion sectors. Let's enter in details about each of them. So the ARCL, it's more or less an operating system that it's used for the Omron AGVs in order as a base for all the application required in our case. It's a simple text-based command and response operating language for integrating a fleet of mobile robots with an external automation system. Allows you to operate and monitor the mobile robot, its accessories, and its payload devices over the network. It is intending for automating your mobile robots. The Enterprise Manager version of ARCL. It's for use with the Enterprise Manager software and appliance. This hardware and software combination have been specially designed and configured to manage a fleet of robots operating in a facility. Therefore, it uses a minimal ARCL command set because of all the critical work is being handled directly by the appliance and Enterprise Manager software, which means the Enterprise Manager software is allocating the task to every robot, to every AGV. It's sending the robots to charging when it's necessary, to parking, and also track each of them. Where is it in the position? How long it take to perform a task, and all these kind of details related to the performance. This is the picture, how it looks, the mobile planning using ARCL. Let's talk now about fleet management. The enterprise management manager, what we call fleet manager, in our case is an e-Tor appliance that makes it possible to use the fleet of the mobile robots. What does it do? Provide one central place to manage the map and configuration, automatically propagating data to the fleet. Provides a queuing manager which match up jobs with the most appropriate robot in the fleet, provide one central point of communication for relation with the robots in the fleet, reduce traffic jams by serving as traffic cop and by sharing location and trajectory information among neighboring robots in the fleet. When should you use one? If you have more than one robots on your production environment and the workspace spaces are overlapped, then you must have a fleet manager. If you want to queue jobs across multiple robots, in almost all cases, if you have more than one robots, then you will need the fleet management. Actually, the fleet management knows every moment where is it each AGV, and when a task is coming, the fleet manager send the task to the closest robot from the point of pickup, and then take care that that task to be performed. We have several kind of communication between the factory floor, between the server room, where it's the application, and between the robot, depending on the situation that we meet on the shop floor. How the fleet manager choose a robot? We can use FIFO or non-FIFO order by priority. In our case, we use the closest robot will take the job. If that robot is not able to take the job and to acknowledge that he received the task or the job, then the job will go to the next one closest to the point of pickup. So we use a non-FIFO order. It will only consider robots that are in an available state, regardless of other characteristics. So if robot is on the charging station and it is below the minimum point, that robot will not be called for not receive a task. Let's go next. When we talk about the traffic management, we have some several situations. First of all, definitely we have the robot performing a task, but then also we have buffering and we have the parking. These are two states of the robot on their period of activity. If a robot is trying to drive to a goal or sector which is already occupied, then it can drive to a standby goal to wait. This is called buffering. In other words, if the robot must to deliver to a certain point on load, and the unloading point it's busy because a previous robot already delivered something there and the operator didn't unload the unlock rack, then the robot, the AGV, will enter in the buffering state in a predefined buffering area. So the fleet management always check if the unload point is empty and it's available to receive the load. So if the unloading point is busy, then the robot will not be able to deliver it and he will wait on the buffering area. Other possibilities that the robot to be in the parking area. Parking is defined when the robot has the battery charge, but there is no task or no job available to be performed. In this case, the robots go in a predefined space and just wait there. This is called parking. And then when there is a new task, a new job to be performed, the fleet manager will call the closest robot from the parking area. If the robot will wait more than 5-10 minutes or a predefined period of time in the parking and will receive no job, then automatically will go to recharging station. Related to charge management, we have several situations based on what happened on the line. On the shop floor, we have auto dock state of charge when the robot reach, let's say, a minimum alarm value. If we set a very low value, 10%, and the robot has to do a long route, then and on this route he reached 10% of charging, he automatically will go to recharging station. Otherwise, it is the danger that the AGV lose complete the battery and stop in the middle of the route without delivering, without being able to move. So it's very important that to have this minimum value of battery level and to send the robot to charging when reached. Low state of charge, it's let's say when the robot will perform the job and will go to charge immediately after the unloading of the charge. In this case, the robot, the AGV, have the permission to deliver the charge before goes to uh, docking, charging docking. Park low state of charge, if the robot spend time on the parking and waiting on the parking, the battery goes to the specified battery limit, then goes there, the robot leave the parking area and go to the first charging station. So these are the limits that the AGV need to take into consideration to define priorities and if will accept or not a load to deliver or not. Definitely, we have also visual control on the robot, so you can see if the battery, the level of the battery, you can see it on the robot, so it's very easy to understand which is the situation in case of each robot. Related to fleet docking, it allows us to tell the fleet that we consistently want some robots to be docked, which means if we need to check some robot to perform preventive maintenance or to verify some sensor and to see, make an update of the software, we just ask the fleet manager to dock a specific robot, and then we will go in that position and we'll find there the robot, the AGV. We can have some strategies. We can say specific number of AGVs to go there on the dock stations, or we can say a percentage of the fleet, depending on the situation that we have on the shop floor. Usually, we call to dock specific number of AGVs because mainly we dock them for preventive maintenance and also for software updates. Percent of the fleet to dock, we don't use it in our situation. Managed motion sectors provide the means for the fleet manager to serve as a traffic cop and decide when each robot can drive and other robots cannot drive. It's like an intersection. You have several robots coming from different direction, several AGVs, and only one can pass, can enter into the room, but there are 3 or 4 wanting to go on the same room on the same time. So in this case, the fleet manager take control of the fleet of each robot, and one of them receive permission to enter into the room or to pass that intersection, and the other are waiting. This means manage motion. It is very important when you have double way alleys with robots, or you have on the same area robots coming from different directions. You will need to have managed motion sectors to be defined and to specify very clear the rules. We'll not enter in details. The same managed destination, it's almost the same situation when you have some robots coming or destination very close one to the others, which can cause collision if you try to put 2 robots on these 2 areas, 2 destinations which are too close. It's very similar with managed motion sectors. In this case, the fleet management will take control of the robots, of the AGVs, and will allow only one of them to enter. And after first AGV leave the position, other AGV can enter in the, let's say, adjacent destination. This is it about more or less a short introduction related to AGVs that we have in our plant in Sibiu. It's a presentation built for, let's say, to become more familiar with what is it an AGV, what is able to do, which are the main characteristics of the softwares. If you have questions.
So if you have any questions, please let us know using the touch functionality as previously, and I'll be glad to forward them. I have one question from my side. Did you have any problems during tests? How long did it take you to move from the idea that you want to have AGV in your factory to actual AGV driving and performing work? So how long did it take to train people to make it run? So how long does it take for a company that just wants to start? Should they plan months, years, weeks?
Now, it's about 1 year. From zero to have a fleet of more than 5 AGVs and to running and people used with them, it takes more than 1 year, more or less, because we decide, let's say, not so straight away. The AGV is coming with some basic software, but when we put the AGV on the shop floor and we start it, we find that there are doors that must be opened by the AGV. We find that the AGV will cross with other ways of means of transportation, like milk run or pedestrian carriages. We find that there is no clear space for the load, unload, or mainly for the unloading on the production area. we find that AGV reach an obstacle in front of the unloading point. So in order to eliminate all these elements, it takes between 1 year and 1.5 years. Now we have more than 2 years since we have the AGVs in the fleet, and we can say that the fleet is running at a very good level of performance, and focus is now to reduce the round trip. We have it's a very important KPI for the AGV, how much time need for drop off, we call it, since the AGV received the task until the load is delivered, and round trip it's complete coming back. Since the AGV is called by the system, take the load, go, deliver it, unload it, and come back. This is the round trip. So now focus is in a increasing number of unloading points and having more and more materials to be delivered, but also in reducing this transportation time, to say it like this. But you will need more or less 1 year, because you will need a lot of unexpected things or elements that you never think that you will need when you work with. The first one, it was this, how to make the AGV to open and close the doors. It was really difficult until they find the proper solution, and Internet of Things applications are here, and to integrate doors with the fleet manager.
Did
The
you
other
have
one is
any?
yeah. Other things was people putting obstacles on the place where the AGV must to unload. So it was a problem of teaching people to leave all the spaces empty. So it takes 1 year. It will be necessary. Yes.
Did you learn everything by trial and error, or did you find some places with best practices, maybe some communities of users of such vehicles that share experiences, or was it everything your own research, your own trial and error, your own learning?
It was our own learning and trial and error, because we were one of the first using the fleet in our company. So we are, let's say, one of the first, if not the first one, then the second one, who put the AGV on the shop floor and start to use it. So there is nobody else from where to learn or to share practices. But at this moment, we are best practice location, and we deliver to other plants full solution. So we design and implement the same solution that we have here to our sister plants in Europe or in the world. But it was trial and error for us. For
Thank you very
Conte
much.
CBU.
Thank you very much. I don't see any more questions, so if you want to ask something, this is a great moment. Okay, no further questions. So one more time, thank you very much for a great, very interesting presentation. And to all of you, thank you for participating. And I want to invite you to our next webinar, which will take place in December. Thanks a lot. Bye-bye. Have a great day.
Thanks a lot. Bye-bye.
Thank you. See